जी दुरानी साहब, मेरी आवाज आपको आ रही है?
आपको आपको मेरी आवाज आ रही है?
जी आ रही है, बिल्कुल ठीक है। बस सर 3 मिनट रह गए, 2 बजे इंशाल्लाह फिर शुरू करते हैं।
जी बेहतर।
जी अभी फॉर्मली शुरू नहीं हुआ। मैं सारे पार्टिसिपेंट से रिक्वेस्ट करता हूं जिन्होंने रजिस्ट्रेशन कराई हुई है उनके लिए लाजिम है कि वो वेब कैम पे लाइव नजर आए। हमें मॉनिटरिंग पीईसी भी कर रही है, हम लोग भी करते हैं, इसलिए अब 2 मिनट के बाद हम शुरू करेंगे फॉर्मली। तो आप प्लीज अपने अब वेब कैम्स ऑन कर लें। जिन लोगों सब ऑन कर सकते हैं, लेकिन इन लोगों ने लाजिम करने हैं जिन्होंने सीपीडी सर्टिफिकेट्स लेने हैं, जिन्होंने ऑफिशियली रजिस्ट्रेशन कराई हुई है। काइंडली अपने वेब कैम्स ऑन कर लें प्लीज।
अस्सलाम वालेकुम ताहिर, अस्सलाम वालेकुम दुरानी साहब।
वालेकुम सलाम। सादिया, तुम्हें थोड़ी देर मेरे साथ बैठना पड़ेगा। मैं जब अनाउंसमेंट्स कर रहा हूँ ना इंट्रोडक्शन, तो आप जरा देखें जो लोग आएंगे उनको एंटर करी जाए। बल्कि ये माउस आप पीछे रख लें अपने पास ही, यहाँ पे, यहाँ से आपको स्क्रीन नजर आ रही है ना? ये वालेकुम सलाम। टीपू साहब की हाल है? ठीक ठाक हो?
ठीक है। मैं क्या लेट तो नहीं हो गए?
नहीं नहीं, आप तो डॉट टाइम पे आए हैं, 2 बजे पूरे। Bismillahirrahmanirrahim. Alhamdulillah, it's 2 p.m. now, and we are going to start our formal proceedings. Ladies and gentlemen, most welcome to the PSCE lecture number 30. The topic is high-rise buildings, outriggers, belt beam, and transfer beam. The speaker today is Engineer REHMAN DURRANI. Now, before I go to the details of the lecture and the introduction of the speaker, I must tell you the rules of this lecture. Number 1, the webcam appearance for those who have registered officially and are aspiring for the CPD certificates. It is mandatory for them to appear live on the screen. It is being monitored by Pakistan Engineering Council and by our staff also. So if we see anybody not appearing live, then I have to stop the lecture, stop the speaker, stop his flow, and it is an unnecessary interruption. So all of you are experienced and I have been attending this lecture. So kindly help me to keep the flow of the lecture in continuation. Thank you. Now, second thing is, when the speaker is delivering his lecture, all participants are requested to keep their microphones off. It should be in a mute position. The speaker has been very kind enough. He has allowed to ask questions during the lecture. And now during the lecture, I cannot allow everybody to ask questions through the microphone. So the best thing is that you type the questions in the chat box and I will read out the questions to the speaker. This will ensure the flow of the lecture continues, and I will ask the questions at a very convenient time. Thank you. And anyway, the lecture, the question answer time at the end of the lecture would be there for 20 to 30 minutes. That would be there. Now these are the 3 basic rules, but I will repeat again that webcam appearance for those who have registered and are aspirant for the CPD certificate have to appear live on the screen. And I hope I will not have to repeat this announcement again. Thank you very much. Now, I just forgot to welcome our participants on Facebook. As you know, this transmission is going live on Facebook also, on our channel, on our Facebook page. And we have some participants there from, I really don't know, they're out of Pakistan. So good morning, good afternoon, and good evening to those who are appearing on Facebook. Thank you very much for supporting us and by attending this lecture. I must welcome my teacher, Mia Saab. I just see him now. Here, Mia Zauddin Saab. Sir, welcome. Thank you very much for coming. So now, as you know, the lecture today, the topic of the lecture is high-rise buildings, outriggers, belt beams, and transfer beams. This lecture is being delivered by a very highly respected professional engineer, engineer Naeem REHMAN DURRANI. As I've said, he's a very highly professional and respected engineer in Pakistan. He's a scholarly person, and he has devoted 40 years of his life in designing, supervision, management of variety of civil engineering projects. Having done his degree from civil engineering in 1973 from University of Engineering and Technology, Lahore, he joined NESPAC and served that esteemed organization for about 10 years. And during his stay in NESPAC, again, he worked on variety of projects in the field of hydropower, nuclear power, Tarbela irrigation channels, and many other projects. Now, I cannot give you all list of the projects, but these were his main hallmarks: hydropower, nuclear power, and Tarbela irrigation channel. For nuclear power, he was sent, I think, by his organization to Paris, France, to get training from a society which trains engineers for the design of nuclear structures. Now, the name of the society in French is very difficult to pronounce. I will try my best to pronounce it. In English, it is Firm of Studies and Equipment des Compagnies. And in French, it is pronounced Société d'études d'équipement entrepris. This is how they pronounce in French. I hope, Durrani Saab, I pronounced it correctly. If not, please accept my apology. Now, after leaving NESPAC, he worked for a company called Floor Arabia. It's a very famous company in Saudi Arabia. I also experienced working with them, not as their employee, but providing some services in Saudi Arabia. Very famous and reputable company. And he worked for Floor Arabia in United Kingdom and Kingdom of Saudi Arabia. Finally, in 1997, Durrani Saab said goodbye for working for the other people and other organizations, and he started his own enterprise. It's called, I think, Naeem REHMAN DURRANI company as a consulting engineer. In 1997, he set up his own business. He's self-employed now, and working for his own enterprise, he has been designing, again, a variety of structures related to office buildings, housing, and leisure and educational institutions. And his hallmark is that he has designed some of the tallest buildings in Pakistan and few deepest basements in Pakistan. So he's a specialist there, and you must have seen on our WhatsApp group that he has been giving inputs on the design of deep excavations, the anchorage system which is required for the deep excavations. And he's quite experienced there. And I have been reading his posts on our WhatsApp group, which has been very knowledgeable and technically very sound. So this was a brief introduction of our guest speaker. Now I give the floor to Durrani Saab. Sir, please go ahead. The floor is yours. Durrani Saab, we cannot see your screen being shared.
Assalamualaikum, and thank you very much, Tahir Saab, for the very elaborate and thorough introduction, which probably I don't deserve. But anyway, thank you very much. As you kindly mentioned, we are going to discuss structural systems for high-rise buildings.
Durrani Saab, we can hear you quite loud and clear. We can hear you loud and clear. Please go ahead with your lecture.
Right. So, the specific building which we are going to discuss at the moment is the Mall of Islamabad. It's a high-rise building with the 4 basements and about 430 feet above ground level. And so it's a mixed use development. It's a mixed use. Sorry.
Just a minute. I am so sorry to interrupt you.
No
भाई मैं
problem.
उर्दू में अनाउंसमेंट कर रहा हूँ, खुदा के लिए अपने माइक्स जो है ना म्यूट पोजीशन पे रखें. हमने आज प्रोग्राम हमने ये घंटे 2 घंटे खत्म करना होता है. इंटरप्शन अच्छा नहीं लगती. So kindly keep your microphones in mute position so that speaker can deliver his lecture without any interruption. Thank you, ji.
Okay. The Mall of Islamabad is a mixed-use high-rise building with retail floors next to the ground, 5 stories of retail stores with large spans and mega columns. So the structural system for the retail area is a beam column system with 15-meter spans. The columns are 750 millimeter into 2,400 millimeter, say 30 inches by 8 feet. The upper floors comprise of an MEP floor 9 meters high with 23 floors for offices and apartments above that. The total height is 430 feet. The lateral loads are resisted by a dual system comprising of special shear walls and an IMRF. The IMRF runs on the periphery and is capable of resisting at least 25% of the lateral loads. The inner system above the MEP floor, which are basically offices and apartments, the inner structure does not participate in the lateral load resistance, and they are just designed for gravity loads. The system is columns and flat slabs with drop panels, no beams except at the periphery, so that services can run without any obstruction. Now, what we have tried to do is that we have introduced on the 5th floor, which is 9 meters high, which is the MEP floor, we have created an outrigger system wherein the core walls are tied to the peripheral mega columns. This not only stiffens up the structure, reducing its first mode period from 5 seconds to 3 seconds, and a 40% decrease in story drift at the roof level, but also lays the foundation of a transfer structure, whereby the location and size of the column in the office and apartment floors above are independent of the large columns in the retail below, which were necessitated by the requirement of having large clear spaces in the retail. The small sized upper columns, that means above the MEP floor, I mean the upper stories are now detached from the lower ones through the outrigger and transfer structure. And so we can choose the spacing and the size. So we chose the spacing from about 18 to 20 feet, and the small columns fit in very nicely in the office and apartments and are not an eyesore. Okay, next. Now this is a Revit model of the structure. These are the top floors, which are offices and apartments, and this is the transfer structure, which is 30 feet, 9 meters high, and below it are retail floors with large spans, and further down you have 4 basements for car parking. You can have a look at the planar view. You have an outrigger structure here and long span retail floors below and short span apartments and office floors above. Okay. Now, this is again, I mean, all this modeling has been done on Revit. Now, this is a Revit view of the outrigger structure. You can see the large shear walls connecting the internal system with the columns at the periphery. And also you can see the columns above. They are smaller and not necessarily in line with the columns below. So we have a lot of space to play with above the outrigger structure. And this again is another view of the same. You can see the transfer structure here. This transfer structure, first we were only interested in putting a outrigger structure, but secondly, when we thought that why not use it as a transfer structure also, because the size of columns was too large to fit into office and apartment floors. So these structures or walls you see here, they take up the load of the upper 23 floors. And they are 9 meter high. And then they finally transfer it down to these mega columns, which take them down through the basement into the next. So just to make it clear, this is the lower floor plan view, and you can see the core walls. You can have all these are lift and lifts, some going to the office floor, some to the apartments, high-speed lifts. And these are the mega columns which support all this retail area. And we could not afford these in the upper area. So we used these shear wall connections from the core to the mega columns, here and here. This space is not empty. It is. It has an opening for equipment, but a 2 meter beam runs over it, which is designed as a coupling beam, so that the pier strength and pier capacity of withstanding lateral loads is not compromised. Now, this is another view of the same thing. It can be clarified. Abhi aap bol rahe hain? Yeah. You can see these are the coupling beams which join the two sides of the piers. So this pier may be considered as almost 75% continuous, and then these lead up to the. We carried up the mega columns from the outer periphery right up, because we needed them to resist shear forces also.
Durrani sir, 3 questions.
Yes.
The first question is from Muhammad Imran. He's asking, how deep is the foundation of the Islamabad outrigger structural system?
I mean, the foundation of the outrigger system, there is no foundation. I mean, it just picks up from the slab and has enough strength to support the slab also, and rests on columns which are, as I earlier mentioned it. But the entire structure is carried on a 1.8 meter piled raft. That's also a special system in which we use, the bearing capacity of the soil in shear is quite large, but the corresponding settlements are also quite large. So we use these piles as settlement reducing piles. So their stiffness reduces the settlement of the raft to less than 2 inches. So this, we run for compatibility of displacements between the soil, the pile, and the raft. Between the piles, the raft transmits loads to the soil, which are in turn additional horizontal loads for the piles, which increase their skin friction. So the foundation is about 20 meters below this level, which we are at the moment discussing. So there is a raft, and below that, a raft 6 feet thick, and below that, piles, more or less at a spacing of about 4 to 5D. And they are 900 millimeter piles, spaced around 4 to 5 meters. I hope I have answered the question.
Sir, second question is from Yasser Mahmood, and he's asking if we change spans of the columns on the top, then in that case, how do we deal with discontinuity of the load path? Because in earthquake, it's problematic.
Yeah, fine. Now, here I get the plan.
And I think there is a comment as to this question. That is, moreover, you mentioned about shear wall transfer system on 5th floor. How does it work?
Yes. Now, as we can see, we have this core wall, which is probably 24 inches thick at the ground floor level, and we have this core wall again. So when we go up, when we go up, these shear resisting elements are retained. I mean, the structure is literally restrained by these large cores, and the earthquake forces go to that, and it is a prime rule that the structure supposed to support the above, the transfer structure, should take no earthquake forces. Otherwise, there will be an unbalance. So you just remember that all these things, and these columns are at the periphery, which are again 8 feet thick, 8 feet by 2.5 feet, they go up. The internal space is freed up. And you can see these small columns here, because we can choose now and these are non-lateral load resisting system. The lateral load system is these special shear walls and a perimeter IMRF, which takes 25% of load. So the system acts as a dual system for PSCE. So there is no, I mean, the lateral stability is not compromised by providing a transfer structure. Sir, have I answered the question?
But Durrani Sahab, you just answered the questions and move ahead. Last question, can we use upturned beam as an outrigger structural system? I think he's asking about inverted beam.
You can use, okay. There is a variety of things. I was going to come to that. You can use steel trusses, inverted beams, whatever you want. We were careful that since we are taking up 23 floors above the outrigger, we thought it prudent to use 18 inches thick and 30 feet high shear walls. You can call them beams also, inverted beams if you want to, but they are important so that when they are tied to when these connect the cores amongst themselves and with the mega columns. Like for instance, you have this shear wall. This is 18 inches into 9 meters, and it takes the shear. It engages the peripheral columns so that the bending moment in the core is reduced. That's the next point I have. So you can see, I mean, these are the walls which are connecting the core to the peripheral columns. But this can be replaced by a deep truss system in steel. It's normally done in steel in the West, and or you can use any other stiff system that does not rotate. Once it is tied to the shear wall. So there are a variety of things you can use, a braced frame or a steel truss or anything. The other thing is that you have to use, these are 2 meter deep beams like this. These are called belt beams. Now belt beams are used because we want to engage all these columns which are not directly being connected to the shear walls. So this, this forms a very, in this direction, this forms a very stiff system. So it stiffens up the system. As I said, the time period of the first fundamental mode is reduced from 5 seconds to 3 seconds. And the story drift at the top is reduced by 40%. So this stiffness has a profound effect on the overall dynamic behavior of the entire structure. In addition to providing a transfer system which is useful for upper floors. Now these are all Revit modifications. Now you can see this. This is the office upstairs. You can see the size of the column is decreased, and it's a non-earthquake resisting column, non-lateral force resisting column. It just resists vertical.
Durrani sir, question please.
Sir?
We have a question.
Yes, sir, please.
As you know, mashallah ji, today we have about 13 viewers on Facebook. Our transmission is going live there. Now,
right.
This Mr. I think most probably Mr. Cam Ran has asked the question, how do you detail the columns that are not meant to be a part of lateral force resisting system?
Yes. There are 2 ways. If you run this analysis with the outriggers and the cores, there will be precious little shear going into the columns. Now, you don't have to specifically detail them because there will be no load, no lateral load. Otherwise, you can create a hinge between the column and the roof. The diaphragm is then not transmitting any moment into the columns.
And one simple question by Mr. Sattar on Facebook. What is the definition of a high rise?
Yeah, that it has many definitions. I think if I can answer that in a couple of minutes, I'll show you a slide, which will explain this. Should I move forward? The question will be answered in a couple of minutes.
As you feel convenient, Durrani Saab, you just answer the question and move ahead. If the person is not satisfied with the answer, he will again supplement his question. No issue. You continue with the flow.
He can go ahead with the because I will answer this. What is the high rise? I'll answer that question.
Please go ahead.
This sort of the same building is built. Yeah, Revit का कुछ दिखाना है? Revit का कुछ दिखाना है? The building is now almost complete. Structurally, they are finishing it. Yeah. Now this is another view of the same thing. We just want you to since it is the system is changing over the floors, we just wanted you to appreciate how does it look like from the inside. Okay. Yeah, ठीक है. This is another view of how the outrigger works.
Durrani Sahab, as you are showing the pictures, just answer a small question again. Mr. Kamar Ali Zaidi has asked, he has just written bearing capacity. So I wonder what maybe he's asking the value of the bearing capacity.
Yes. We are 4 basements down and the gross bearing capacity is around 2.75 to 3 tons per square foot. But the ultimate shear capacity of the soil is 9 tons per square foot. Now, you know, if you apply a factor safety of 3, you get something like 3 tons per square foot, but the settlement is large. So, to counter the settlement, we include piles, which if you model them as springs and apply the load from the top, the settlement of the entire raft starts reducing. Otherwise, it would have gone to 250 millimeters if we don't have those piles. So those piles stiffen up the soil, increase the bearing capacity, and decrease the settlement. Does that answer the question? Okay. Sir, should I move on, or is there a similar question elsewhere?
No, Durrani Sahab, you please continue with a free flow, no issues. Whenever there is a need to interrupt, I am there to interrupt you. You please go ahead with your convenience.
Right, thank you. Now, coming back to this, what is an ideal structure from a structural engineer's perspective? We call it the zero premium structure, which in simple words means a structure designed for gravity loads, does not require further strengthening for later loads. As we all know, there are different load factors for gravity loads alone, gravity loads acting in conjunction with later loads, etc., etc. So the ideal structure is one which, I mean, it's no harm in striving for an ideal or a zero premium structure, but even if it is has a premium of 10 or 15%, I personally won't mind. But the system should be designed as such that the gravity loads as they are would require certain amount of reinforcement and structural members and concrete and steel or whatever. But when we go into later loads, the load factor of the gravity loads diminishes, almost goes away. Like for instance, the 1.6 factor for live loads, that diminishes to 0.5. So, but we add earthquake forces, and our desire is that the reinforcement requirement should remain as nearly as possible as for gravity loads alone. Now these are the various. I'll just quickly run through. This is all textbook stuff, but the next slide. ये तो हो गया.
Durrani sir, we have a question from engineer Hamid Ismail, and
Yes.
he is asking for a pile raft system design, and from geotechnical standpoint, what are the geotechnical precautions, recommendations necessary in a safe and economical design?
Yeah. I mean, these pile rafts were very common in Europe for the last 30 years, especially buildings in Frankfurt. The Americans were hesitant to adopt it. Now they have adopted it. Now, it is quite a laborious thing. Paulus has written quite a few papers on that. It has become now almost a standard practice. Now, what we have to, the interaction between the pile, the soil, and the raft, that has to be incorporated. And in each case, the system should be iterated so that all three displacements of all three elements are the same. Now, one thing, I mean, that would require a lecture on its own, actually. It's a complex thing, but I'll just run through it. When the raft transfers the load to the soil obviously settles, but there are piles on each side. Now, if the vertical load is increased on the soil, the lateral load of the soil is also increased, which acts on the piles. And the piles are restrained from both sides by this lateral load. Hence, their skin friction carrying capacity is increased. Now, we model all these as the pile is modeled as a spring, and what we include is a real pile load test, and at 1% of the diameter of the pile, whatever the settlement was, and the corresponding load divided by that settlement is the spring stiffness of the pile itself, to be sort of easier to follow. And the soil itself is represented by soil springs like everywhere else, but those soil springs need very careful careful thought, because they are now the soil is not an infinite medium as the assumptions in the geotechnical area are. It is not infinite because it is confined by piles. Just imagine a 4-pile system, and inside it is the soil. Now this soil is constrained. It's not free to spread laterally. So that helps the soil also. And that is why these piles, we are not very concerned how much load they take. We are more concerned how much the settlement do they reduce. Because the total load carrying capacity of the raft, the soil is enough to carry the entire load. But with the deflection, but with a settlement of 250 millimeter, which nobody will accept, and which will produce differential settlements and the lot. So this, in short, is what we try to achieve in a piled raft. But if there are significant number of geotechnical engineers interested in this, I can, after a few weeks, give a lecture on that, because that is also a very interesting topic. Should I move ahead, sir?
Durrani Saab, we have actually, we are flooded with questions now. The next question is whether we can call it as a partially floating foundation. This is from Kamar Ali Zadi.
Yeah, you can call it a partially floating. In fact, it is partially floating anyway, because you have excavated 20 meters. I mean, you have removed 20 meters of muck. So that what you have removed, unless it is some sort of an expanding soil or something else, that is the load which you can add to bring it down to its original position or almost to its original position. So you can call it a type of a floating raft, because, but the better name is, because it relies on the float also, the removal of muck, but includes a very important component, which is the piles.
Yes, sir. Next question. What are the basic assumptions of material and geometrical behavior in outrigger structural systems? After that, we have two more questions, sir.
Sir, outrigger system, the material, as I said, there are no special requirements, 5,000 PSI or 6,000 PSI raft, shear wall, or any other truss system, A500 or even A36, depending upon what height it is. Because this structure is 3 floors high. I mean, there's quite a factor of safety involved in this. But yes, I mean, you can use A36 steel trusses or A500 or concrete or composite sections even, steel and concrete in combination. So that's your choice, whatever you can. I was a bit reluctant because, you know, we are not very good at detailing and executing the steel structures. So I stuck to the concrete, but I don't claim it is the most economical thing to do. It could be maybe the steel trusses would reduce weight and be more economical, actually. Yes.
Durrani Saab, now we have questions on, it has become more or less like an interactive session. So anyhow, we have to continue with it. Now, Ehsan Sattar is on Facebook. He has asked, outrigger normally connects edge columns to core. Some of the outriggers are not connecting columns to the core. They are just connecting edge columns. Are these transfer beams only and not outriggers?
Absolutely. That's absolutely right. Because we need, I mean, the core does not span the entire floor. So the core is strengthened by the outriggers, and the other deep beam structures, you can call them deep beams or shear walls or structural walls. They are meant for supporting the load from the top, the gravity load. And they do not play any major part in the stiffening effect of the outrigger.
Yes, sir. Two more questions. Mr. Kamran, I think he's a new entry in our participants list. He's on Facebook. And sir, please note it that we have about 30 to 45 seconds lag on Facebook. This is some technical issue. It always happens. So Mr. Kamran is asking a question. In continuation to the last answer by Mr. Durrani, the lateral stiffness in the structural model can be modified, reduced to minimize attracting lateral loads. But practically, how does it work? Practically, you are placing the actual size of concrete columns and its stiffness will actually attract some lateral forces. How will that be controlled to not take these lateral loads? At level 0.5 are a part of long transfer columns are resting directly on the slab.
Yes, the important thing is that we need stiffness in buildings, in high-rise buildings which have apartments on the top floors. The reason being that if we have long periods and high wind accelerations, the comfort level of the occupants of the apartment reduces. Because an earthquake is a force which would be for 30 seconds or maybe 1 minute. And by the time people would have, if it comes at night, people would, wake up and go towards the exits or other things. But this wind, this high wind which creates turbulence also in building is a phenomena which goes for about 30 to 40 minutes at least, or maybe 3 to 4 hours. And it is very uncomfortable for the occupants to, do work or go to sleep or do anything else. Now this system definitely is stiffer than a system without an outrigger. There's no doubt about that. But its period is smaller and is more suited for apartment floors above. Now, you have to strike a balance between what you want to achieve by intermixing all these structural elements and come to a system which is acceptable to various trades. Now, if we introduce an outrigger, that will definitely reduce the period and not necessarily increase the force, because if you have a response spectrum in front of you, if you are on the, and normally I am, on the plateau of the response spectrum, either moving right, meaning increasing the period, or moving left, decreasing the period, apparently does not affect the level of force. But if we increase the period to the leg which goes down, you will reduce the force, but increase the sway. Both of them have to be balanced out. So, do I answer the question?
Yeah, you answered it. I think, Durrani Sahab, we will have to stop the questions at this time because the lecture cannot move. In this way, I think we will not be able to keep the lecture in our specified time, allocated time. So please, you continue. Now, all participants here on Zoom and on Facebook are requested to, they keep on asking the questions. We will keep a note of it. At the end, we will ask Durrani Sahab your questions. And inshallah, each and every question will be answered. Don't worry about it.
Inshallah.
Please continue, Durrani Sahab.
Right. This is a simple, just an illustration. This is the Burj Khalifa which was erstwhile called the Burj Dubai. And it has a central core, as you can see here. And then there are walls running like this on a triangle. And these red are the outriggers. So they stiffen up the entire thing. And this wall is about a meter thick. The wall which connects to the central core, this one, is about 1 meter thick. And these outriggers are about 60 centimeters thick and apparently about 3 stories high. So this was just an example of that. Now I just quickly run through this. I mean, for what the question was, what are high-rise buildings? The high-rise building can be anything. I would classify in Pakistan something like 25 stories and above as a high-rise building. Because a high-rise building, according to the CTUH, which is the urban habitat sort of website, and they say that any building which requires, due to its height, special systems for its stability and its economy and its workability, that is classified as a high-rise building. So anything which requires things like outriggers, etc., is a high-rise building, if it requires that and is not imposed. Now we have this. This is an international standard, but this is framed with shear truss. You can take it up to about 45 floors. This is a shear wall and framed with shear band and outrigger trusses. So we are about in this. This can go up to 60 feet, but it can go up to maybe. You need to just increase the number of trusses, and I've seen buildings going right up to about 100 stories. So this is just most of this was created by our Bangladeshi brethren, Fazlur Rahman Khan, who used to work for Skidmore, Owings and Merrill. And he did this work in 1956. He is the father, he's still called the father of high-rise buildings. So this was just, now I just want to get some analytical stuff over so that one can understand what it is. Now this is a shear core, and this is an outrigger structure. And this is, it can be any material, like I said earlier, trusses or concrete or shear walls or whatever. Now we have, this is an idealized form of seismic load. Now what happens is that the shear core acts, as you know, as a cantilever. So its deflection is 3 times. It's a cube of the height of the shear wall. Now, if you introduce outriggers here, so the curvature of the wall is modified, and the peripheral columns take part in bending, and hence reduce the bending moment in the shear wall. And this is the principle on which the outrigger system works. Now, in other words, what we can say is that it creates a spring here, which is in opposite direction to the moment created by the lateral forces. So there will be, compression in this, maybe tension in this column, compression in this. This will form a couple, and resist and reduce the bending moment in this core, as well as because it modifies the curvature. Now this is an example with a simple shear wall without any outrigger, and this is with an outrigger. So the moment diagram comes like this, and at the point of the outrigger it abruptly reduces and then carries on downwards. So the advantage is that the width of the area which is reducing the bending moment is increased from just the core to the core and peripheral columns. So this is how we define. You can see this is the shear wall. Had there been no outrigger, it would have deflected by a function of L cube. And with the outriggers in position, I will next show you that how do they affect it. Now, if you just want to put one outrigger in a building, the optimum position, and this can be checked from first principles and closed forms equations. I mean, there's nothing very special about it. There are some assumptions you got to make, but clearly, if the position of the outrigger should be something like 0.455 times the height from the top. And if you want to have two of them, so the optimum place to put the outriggers is this. It's 0.69 from the top and 0.31. Now, these are interesting curves. Now, suppose I put my outrigger at say 0.4. Now, this is outrigger position H over total H. This is being done from bottom. There is a dimensionless equation determined by engineers, which is a ratio between the stiffness of the shear wall and the stiffness of the couple generated by the outrigger in the peripheral column. So if I have 0.4 and this is 1, so I will reduce, this is the normalized outrigger moment. So if I have 0.4, 1, so I will have reduced the moment by 0.35, 35%. And if I put it at the optimum position, so it will, well, it doesn't make much of a difference here. But if I have a stronger outrigger and I place it at 0.4, because this term is increasing, so it will take something like 50% or more of the bending moment in the shear wall. So that is quite a significant reduction. Now this now you can see here the roof deflection. Now delta is with no I mean with the outrigger in position, and this is without the outrigger in position. So again, if you have a K of 0.5 and you are reducing the top deflection by 45%, which is quite a lot. And one of the reasons for adopting this was because to reduce the earthquake, the wind acceleration on the top. Okay. Yeah, I think so. Yeah, complete हो गया. बस ये तो last slide तक all को हो गया. So now we are. I'm ready for all the questions now. Sir.
Thank you very much, Durrani. The lecture is almost finished. Now we can start with the questions.
Yes, sir.
Now, first, I will read out the questions which I have got in my chat box. And then, sir, anybody likes to ask the question, he has to raise his hand, and then I will give him the chance to speak on the microphone. So the first question is from Hamid Ismail. He's asking, by using large diameter piles, would it result in greater distance between piles, hence a much thicker raft? So would it help to use smaller diameter piles to be closer, hence thinner raft?
Yes, that's right. But there are two parts of the question. One is, if you have piles which are largely spaced, not necessarily larger diameter, but maybe 900 millimeter or 1000 millimeter, but spaced at say 5 meters, not 3 meters like 3D, but 5 meters. The area within the piles, which is capable of taking load, albeit with larger deflection, that part increases. And there are a numerical analysis carried out, and I think optimally 30% of the total load, if you want to convert it into what load the pile takes, so it would be about 30% if the pile is spaced at 4 times the diameter. And larger piles, yes, because larger piles leave very little area in between for the raft to act as a traditional raft. And as I said, to create lateral loads so that the piles can have additional skin friction. So you have to, in fact, make a balance between these. What diameter you select and what spacing you select. And there are, computer-generated graphs and other things. And if you know the Young's modulus of the soil, and that those can help you very much in, deciding which option to go for, or what size of pile to go for, and what spacing to go for. There is some input from the roof level, from the structure also, because at some points in the structure, like core walls, etc., the piles are required in any case to take additional loads and bending moment. So, just coming back to the question, the question can be answered in more than one way, that you can reduce the diameter of the piles provided you are taking enough load from the top, and your spacing is enough so that there is a chance for a direct transfer of vertical load to the raft. So you have to maybe make some iterations or do that. But in principle, what you said is correct. I quite agree with it. Smaller diameter piles, largely spaced, would be much better option than large piles closely spaced. Do I answer the question, please?
Next question, Durrani Saab, it is from Salman Rafiq, and he is watching this transmission on Facebook. He is asking, please elaborate consideration of overstrength and redundancy factors considered for design of transfer structure supporting transfer structure.
See, and the transfer structure itself is a gravity load resisting system primarily. I mean, it does not to any significant extent participate in the earthquake resistance. Now, by overstrength, you mean if the transfer structure has more strength than required, what happens? As it is not part of the lateral load resisting system, it will have no part to play in the lateral forces. And I mean, we normally ignore any effect of this on the lateral load resisting system. But if it is, I mean, a transfer structure can be a slab 3 or 4 meter thick, or walls, or other things. Only those walls which are tied to the cores, they are the ones which are resisting or adding to the capacity to resist lateral loads of the entire system. The other walls, which are just transfer structures, have no significant role to play, because in the presence of the core and its connection with the peripheral mega columns, this wall does not go down into the basement, hence can't, it has no foundation below that. It is just there to take the load from the top, spread it, and put it on the columns which have been removed below the outrigger structure. So it has, I mean, even if it is over strength, it will not play a very insignificant role in the lateral load resisting system, maybe not even 5%. Because one, it is not tied to the cores. Number two, it does not have a foundation. Now the cores have a foundation and the mega columns have a foundation. And hence, they are responsible for taking most of the lateral loads. And in this case, it was something like 90%. So, sir, do I answer the question, or?
I think you have, if he is not satisfied, he will ask the question again. Now I'll ask another question. This is from Yasser Mahmood. He is asking, how do we differentiate between bearing capacity for here and bearing capacity for the settlement? Yes, sir, please go ahead.
Yes. Okay. This is a question which has been a bone of contention between structural engineers and the geotechnical engineers. Now, what we differentiate is, see, we have a raft foundation, and we have shear capacity of the soil as say 10 tons per square foot. Now if we apply a normal factor of safety of 3, we get something like 3 tons per square foot. Now if we apply that force on a Winkler spring model or any other software like Plexes, etc., which are more thorough, you may find that at 3 tons per square foot, there is a settlement of say 6 inches, and which is not acceptable to you. So the geotechnical engineer works back and sees what sort of a bearing capacity remaining within the 4 confines of the shear capacity of the soil. What bearing capacity should he give to the structural engineer so that his settlement for the raft remains 2 inches or less, and for isolated footing 1 inch or less. Now, there is some sophistication in this, whether you take out you provide a gross bearing capacity or a net bearing capacity or that. But the basic principle is this, that invariably the shear capacity of the soil is much higher than what we are using because of the constraint of settlements. Does that answer your question?
Anybody who wants to ask questions on microphone, then please raise your hand. Raise your hand means there is a function in Zoom. You just have to click that function, and I can see your hand on the screen. Then I'll allow you to ask a question. Sir, the next question is from Muhammad Imran. What are the topology and size of outrigger belt beam system?
Yeah. You can, the rule of thumb is that it should be about 2 to 3 stories high. The system, may it be a truss system or a shear wall system, it should have a height of 2 to 3 stories in order to be stiff enough to transfer the moments to the peripheral columns, and most importantly, reverse the curvature of the cantilever core wall. So the rule of thumb, you can iterate and find out whatever is best for your building. But the rule of thumb, which is internationally accepted, is that it should be between 2 to 3 story high.
Yes, sir. The next question is again from Muhammad Imran, and he has asked, what are the most suitable outrigger locations and outrigger numbers?
Yeah, yeah. Yeah. Now, Mr. Imran, if you have just one location, you want to provide an outrigger at one location only. You can't, there are many restraints to where you can provide, you would need clear space of 2 to 3 stories, which normally is available in MEP floors, but there are not many locations. So in this building, we provided only one outrigger. Another building we are doing, which is about 500 feet high, we are providing at least 2 of them. Now, the optimum location If you are interested, I can put in the equation you can use, is that from the top, it should be 0.455 H, which means almost in the center of the building. Now, if you put the outrigger at any other position, it will not be as effective as this is. This is the optimum found from closed form solutions. Now, now, this is the optimum location of two outriggers. I mean, if you have the luxury of having two points, and normally in building about 60 stories or 50 stories, they do provide MEP, more than one MEP floor. I mean, they have their own problems of transmission of fluids and water tanks to be placed at mid height so that there is not much water hammer or things like that. So this is if you have the luxury of providing two of them, this is the height where you should provide them. Right now, I just showed this just to give you an idea. I mean, this equation includes the Young's modulus of the shear wall, the core wall, and its moment of inertia. And the bottom term B is the distance between the outer columns. Say, I mean, whatever the width of the building is, that is B. And then this and this are almost the same because the shear core and the columns have almost the same Young's modulus. And this is the area of the column. So the lesser this quantity is, the more stiff your outrigger is. Now, as I said, if you provide an outrigger here, right, and you have a very stiff system like which gives you K of 0.25, right, this value, because the column area is large and the inertia, as compared to the inertia, the K value turns out to be small. So if you are using this curve and you place your outrigger at the optimum location, that was from the top, so from the bottom it would be something like 5 here. So if you go here and you have a K value of 0.1, you come down, you will have an outrigger which takes 55% of the moment, the total moment. Only 45% goes to the shear wall, which lightens it up quite considerably. इसके बाद यार ये आगे ये क्या है? ये उसका ओवरटर्निंग मोमेंट है। नहीं वो तो पहले क्या था? वो नॉर्मलाइज्ड आउटरिगर मोमेंट। अच्छा, वो आगे चलेंगे डिफ्लेक्शन में। Now you have this, the same quantity here. If you apply it here, and you have a K value of 0.1, your reflection at the top would be reduced by 80%. Well, this is significant. The columns apparently are large, so that this figure becomes this. So coming down to a more realistic value, if we use this at the optimum location, I'm just talking about one outrigger at the optimum location, so that we don't want to mix up too many things with two of them. You can actually work that out. When you come down, you will find that you have reduced the top deflection by 42% or 43%, which is significant. I mean, a lot of these tall buildings are very sensitive to story drift. And if you have an outrigger, it will help you very much, even with the with a value of, say, 1 or more. I mean, if you have a very light system of outrigger, you will reduce the top story drift by only 15%. So it all depends on your, where you place that is almost fixed, where it will act at the optimum level. But your columns and shear walls, the relationship between their properties like moment of inertia and area play a role in this. So I just gave you 1 or 2 examples, but properly designed and detailed outrigger should be able to reduce your story deflections at the top by about 40%. This was done in the example I showed you. This is what happened. The period was reduced from 5 seconds to 3 seconds, and because they added stiffness, although we did not place the outrigger at the optimum position, because our hands were tied, we had an MEP floor there, and those guys were not ready to move it up or down. So we had to put the outrigger right there, which was, I think, from the top was 60%. So it was not optimum, but it did its job. And it is not an ideal world, so we have to make compromises and do this. Do I answer your question, sir?
I think you have. If he has any supplementary, he can ask. You see, we have another 20 minutes to go, so I'll just try to finish out as many questions as possible during this time. Now we have about 3 questions from Facebook. Let's get the answer of these questions first, then I'll come back to the questions being asked here on Zoom. Durrani Saab, I assume he's Mr. Kamran, but he's writing his name as Kamran. I don't know. I hope I'm right. Anyhow, he is saying, my apologies. I may not have been clear in my last question. I was actually interested to know that during construction, how would you detail the inner columns to take only gravity loads and avoid attracting any lateral loads at a certain story level? And his second question is, at level 05, some part of the transfer columns are directly resting on the concrete slab. How has this been catered for in the design of these slabs?
No, there is no transfer column which rests on the I doubt if there is any column which is resting on. They all rest on walls. They all rest on walls. Now the shear walls, I'll go down first. ये भी और ये
जी सर, वो ग्राउंड फ्लोर है, वो फिफ्थ फ्लोर।
Now, this is what is down below. I mean, there are shear walls running here, which are not outrigger walls, but which are transfer structures. These are transfer structures. Now I come to the floor above. Now all these grids have shear walls. So there is, I mean, apparently there is no column which, I mean, we kept the grid upstairs because we put the shear walls on the, on the grids. So all these columns in between at spacing about something like 6 meters, these columns all rest on shear walls. So there can be, I mean, as I said, the discontinuity in the shear walls, as was shown on the Revit model by rotation and looking at it from the inside. That opening, if I understand correctly,
जी सर,
ये नीचे वाला
चाहिए, वो ऊपर है।
Now this is it. Now this is not a slab. This is a 2 meter deep coupling beam. You can see this. When there is, I mean, we have to leave some space for equipment, placement. And this, we have to provide an opening in the wall. Now, above that is a 2 meter thick beam with a very small span, maybe 4 meters or 5 meters. There may be some columns which come on this, but this again is part of the transfer structure. Most of them will come on the grid lines. And the grid lines, I mean, all these columns are on the grid lines. And on the grid lines, you have either a through shear wall, 9 meter high, or where the spans are small, a beam 2 meter thick with a span of just this, so that it does not deflect and transfers the load onto the shear walls, which are 9 meters thick. And these are, as I said, these are only transfer structures, and these are not outriggers. Do I answer your question, sir?
Yes, sir. Next question is from on Facebook from Mr. Ehsan Sattar. Why the core walls are unsymmetrically arranged? There must have been architectural constraints, but outrigger systems rely on push-pull action of edge columns against central core. How is torsional movement controlled for this building?
Yeah, this building had a requirement because it was feeding two sets of occupancies, one for office and one for apartments. And the architect deemed it necessary to separate the pools. Now coming to the structural part of the question, the core needs to be connected to the peripheral columns for for the outrigger to work. Now that core is being connected to the peripheral core and this one, and this also connects the two cores together. So that provides a very strong line of defense. Now, yes, there was torsion, which a structure like this will have. And obviously, the first outrigger system was designed for a center core, and that was about 60 years back. Now, I mean, if you want to take the easy way out, you put a huge shear wall right in the center with all toilets and facilities and everything and lifts, and then tie it to the outrigger. That is no, I mean, well, that may not suit architectural requirements, and but it's very easy. It has been done in a building which is maybe 60 floors or 50 floors in Karachi, Bahria Icon or whatever. But the structural system is very primitive. It came to me for review. It's very primitive. I mean, it has a central core and columns all around, and very little space is left. I mean, there's no flexibility. I mean, you have just a core and a column at the periphery, full stop. Now this one, yes, we had to deal with torsion and had torsional irregularity, but it also suffers from vertical irregularity, which is more important. The stiffness of an intermediate floor is 3 times as much or maybe 10 times as much as the floor above. And if you are following PSCE, this comes under the head of vertical irregularities. So one shouldn't be very afraid of irregularities if you can address them. And you have a strong reason to place the cores where they are being placed. I mean, that is a cut and dried solution to put the core in the center. Which would, which would mean that an outrigger system cannot be developed unless there is a central core, which is not the case. So, yes, there was torsion, and that can be done. In fact, from day one, we were using the response spectrum analysis. What those irregularities mean is that you go for a higher form of analysis. And you cannot do it with the ELF or lateral load, simplified lateral load system or whatever, because it has eccentricity, it has torsion and vertical irregularity. But those are things which engineers have to accept and expect and to deal with. So do I answer your question?
Durrani Saab, we are now getting tight with the time, but still we have 7 questions to follow. So I would request you to just go for a short and summarized answer so that we can accommodate all the questions. And if any participant has still some thirst which has not been quenched, we can they can email us and we will send you the questions later for the detailed answer. So kindly just now answer these remaining 7 questions in a summarized way so that we can accommodate them. Now it's Salman Rafiq on Facebook. He is saying, thank you, Durrani Saab. But again, my question was actually that there were the columns and cores supporting transfer structure designed keeping in view PSCE overstrength and redundancy considerations. Secondly, I can see cores are eccentrically located. Was it due to architectural reasons, since it can generate amplified torsional effects? Thank you.
Yes, they were designed, they were placed there because of functional requirements, and they were, dealt with accordingly for torsional effects. And the first part was that there was, could you kindly just give me a hint? What was the first one?
Yeah, the first was that there were columns and cores supporting transfer structure designed keeping in view ASC overstrength and redundancy considerations.
Yeah. Now, as you know, these this is a very relevant question actually. Now this one. Now this all these walls have one column in the center. I mean, this is a 3-column system. One column runs, one beam runs below the outrigger 15 meters. Now these walls, when they take up all the vertical loads and lateral loads and transmit them to the columns below, which are इसकी कोई है नीचे नीचे की कोई वो है ये जो नीचे ये इस पे क्लिक करो. Now the shear walls above are transferring loads to these 2 columns and all columns which are not even if they are part of the outrigger. Now, when they transfer the load to these columns are designed for a shear force of omega, which is 2.5 times the shear force being transferred. This is directly from PSCE. So you have an overstrength factor, and you can't live without that, because you are transmitting loads from a continuous wall to discrete columns. So the code requires that whatever the shear is, you multiply the normal load factors notwithstanding, you multiply it by 2.5 and design these columns with stirrups from the top right to the bottom. And this is, I mean, the redundancy in the system is taken care of by this. Discontinuous shear walls transmitting load to the column will have overstrength factor of 2.5. I think it now probably would answer the question.
Yes, sir. And I had another question on Facebook from Abdul Hannan Ahmed. He's asking, why is it necessary for the design team to go for this type 2, regardless to the number of floors? Why not some other type be selected?
Oh, well, as I stated earlier, there are 2 reasons for using this. One, to stiffen the structure, use an outrigger and do it. And for the outrigger and other structures to act as transfer structures, because you can't take these huge columns up into the office and the with the space left between the, it would be not workable. So we want smaller columns, smaller spacings, so that they can fit into the the block masonry walls or the partition walls, or otherwise these would be an ISO. And lower down, it's a retail area where these columns, I mean, they are better off without these columns, so that they have enough free space to carry out their activities. But this free space is not required above. And if you use these beams, which are 1.2 to 1.5 meter deep, if we use them upstairs, by using this transfer structure, we have added 6 more floors because of the fact that we have eliminated the beams, used a flat slab with drop panel system, and the height of the floor to floor height was reduced from 16 feet to 12 feet, and the owner put in 6 more floors at the same height, within the same height restriction. That was one of the major reasons for using a transfer structure. Now, what else can be done? I'm sure there must be other alternatives, but this is one of them. If they can, I hope I have answered.
So on Facebook, it's again Kamran. I think, yes, I think one part of his question remained unanswered, and he's asking again that the first part of my question has not been answered. Construction detailing of columns to support gravity loads and not attract lateral loads.
Yeah. In this case, the columns are so small and the shear wall system is so stiff, they hardly take 3% of the lateral load. So if they take 3%, we don't need to detail them. I mean, had they been taking 25% of the lateral load, and we did not want them to take that, so then construction detailing, can include the formation of a hinge, which means typically detailed reinforcement, which is incapable of taking any moment.
Okay. Now, Durrani Saab, we will. नहीं Facebook का काम कर दें, टाइम 15 मिनट रह गया, तो ईमेल कर देंगे, no issues. Durrani Saab, we have now 6 questions. Now we are coming back to the questions which are being asked here on Zoom. Now, any question I will receive from Facebook at the end, if we have time, I will ask. Otherwise, we will send you the questions. You can respond to the applicant via email. We will give you the details. Now, coming back to the questions here on Zoom. Muazzam Nawaz, I think you must have now understood what are the outriggers, but still I will ask Durrani Saab to tell you briefly that what he's asking, sir, what is outriggers as this is totally new term to me until now in my professional career. So I think he must have understood by now, but if you want to still explain.
Yeah, I think we have elaborated much on the outriggers and their need and their advantages and disadvantages, whatever.
Yeah. Okay.
And by the way, because it has not been used very extensively in Pakistan, it is very likely that some of our engineers are not familiar with the term. But let me assure you, this was, the first outrigger was placed in a high-rise building as far back as 1970. Oh. And now it is, as I showed you in Dubai, the Burj Dubai, there were at least three sets of outriggers in the entire height. So they are useful things.
It has a history of 50 years now. Anyhow, now we get a question from Kanwar Majid Ali. He's asking, although this question is not relevant to this lecture's topic, but this question will help me in future career. While calculating the integrated steel structure, how moment release points at connected nodes can be considered and calculated? Sir, if he must be a young engineer, if you can give him some advice in a short time, please.
Yeah, if I understand the question correctly, I mean, he wants to, in his structural analysis, he wants to put in a point where the moment is zero. The best thing to do that is to create a hinge, and all software have that capability. And put a hinge in there. I mean, you have 6 degrees of freedom and if you release that moment degree of freedom, there will be no moment, and the structure, although will remain stable, unless of course there are too many hinges, but will conform to what the questioner has in mind.
Yes, sir. Next question is from Yasser Mahmood. Sir, for the column in the middle, which are not supposed to take the lateral loads, how is their modeling done in the software? Since bigger periphery columns are the ones which are taking the 25% lateral load.
Yeah, for this, as so far as the modeling is concerned, if you in that run, in the run for lateral loads, if you put a hinge between the column and the roof, which is the diaphragm, if you put a hinge there, there will be no transfer of moment. It cannot take any lateral load and will satisfy your condition.
shear modified भी अप्लाई किया जा सकता है ना टैब के अंदर, और फिर वो उसका shear area 0 कर दे, so that it does not go.
Yes, there are many other ways. Like my friend here told me that if you can enter into ETAB's modifiers and modify whatever you want to, be it shear or moment or whatever, then that element of force will not be transferred to the system within that run.
Yes, sir. Next question is from Hamid Ismail. He is based in Jeddah, Saudi Arabia. He's asking, can the Honorable Speaker recommend a suitable reference paper we can consult to understand the geotechnical aspects of raft pile system, and especially the paper reference that specifies that at least 30% of the load shall be taken by the piles?
Yeah, let me correct. I said it can, with this sort of spacing, which I mentioned, almost 30% of load would be taken up by the piles. Now, there are many papers on this, and I have quite a library. If there is some place I can upload this, I would be very happy to do that. How does PSCE have a library or whatever? I can, if he gives me his email address or anything, I can send it to him directly, or put it on the PSCE website so that others can also access it.
Yeah, that would be very kind of you, sir. If you can send the paper to Sadia Naveed, she is the coordinator. Okay. She will place it on.
Yeah, I have quite a library of those, starting from the days when it was first used. So I'll do that first thing.
Now we have a question from Mr. Adnan. His name is not coming. Second name, I cannot read it. Anyhow, Mr. Adnan, can we correlate the mall of Islamabad and with K and H total? I could not understand the question. Can we correlate the mall of Islamabad with K and H total? What is the value of K and H / total for your project?
Which hotel, sir?
This total he's asking, H total. Okay. Adnan Mahmood, please ask this question. Unmute your mic and ask this question. Please go ahead.
Sir, मेरा question ये था कि basically आपने जो ये ग्राफ्स दिखाए थे, जो आप जिसमें K की वैल्यू आप कैलकुलेट कर रहे हैं, तो आपके जो स्ट्रक्चर है उसकी वैल्यू क्या है बेसिकली? आप जो खुद मतलब आपने जो यूज किया है जो टेबल को कोरिलेट करने के लिए, जस्ट टू अंडरस्टैंड, दैट्स व्हाट आई वाज।
जी हमारे जो स्ट्रक्चर था उसमें जो ये जो quantity थी ऊपर दी हुई, this worked out to something like almost one.
Yes, sir. Now the last question we have on Zoom is, in outrigger steel, more than 60 grade can be used. Basically, he's asking, can you use the 60 grade steel in the outrigger?
Yes, you can use up to 75, grade 75, not 100. You can't use 100 because of lack of ductility, but you can go up to grade 75.
Okay. Now we have come to our last question, and it is on the Facebook. So inshallah, we will be finished with the questions. This is asked by Shafiqur Rahman, and he's asking, any analysis performed related to differential shortening of cores and columns due to elastic and creep oblique shrinkage effects in high rise, especially when core is unsymmetrically placed?
Yes. I mean, what I understand from the question is that the questioner wants to know if there is, in a high-rise building, there is shortening of columns, or if it acts as a couple, there is tension on one side and compression on the other. What effect does it have? Yes, this effect is automatically catered for. There is shortening due to gravity loads, and there is shortening due to lateral loads. And this is part of the analysis. And normally what we would like to do is to carry out a staged analysis. I mean, at different stages, how much deflection do we expect, so that the constructor can incorporate that in his own levels. Although these are small, but they need to be adjusted as the structure is built.
Now we have all questions answered. So if there is anyone needs any answer to any question, kindly raise your hand, or they can type the questions. We have now hardly 2 to 3 minutes left, and I have to give the closing remarks also, but still, if anybody has a question, most welcome. You are okay, give it to me. We have a question one on the Facebook. Sure, this is Mr. Yasser Salim, and he is asking, anytime history analysis carried out or displacement based design checks. So basically, I mean, he's asking a question that, have you made any design checks on history analysis on displacement based history analysis? Design checks, he's asking.
I mean, he's asking for a time history analysis.
I think so. The question is phrased in such a way that the English is a bit confusing. Any time history analysis carried out or displacement-based design checks?
No, well, we may have done it at training courses or other things, but it's not a standard design office practice. Why? Because we have a response spectrum, and you have to match the time history with the response spectrum. So the time history is not the actual depiction of the earthquake, but it is a synthetic depiction of the earthquake. And since we don't have enough data, Yeah, we don't think it is at this time. It is the right time to introduce it into design offices, because the data required for such analysis, which is perhaps quite commonly carried out as in the West, we don't have the data. And if the data is inaccurate, there is no fun in going into such an elaborate and mathematically very elaborate system. I mean, the response spectrum, as stated, is the standard in all design offices. Time history, yes, but in research or nuclear power plants or something like that. But they have to have an original time history and not a synthetic one.
Thank you very much, Durrani Saab. Very knowledgeable and on our lecture on the high-rise buildings. That was, I think, from the questions we have got on Facebook and here on Zoom, they speak of the quality of the lectures, of the lectures that you have delivered. And it looks like the audience was quite engrossed with you while you were giving the lecture. So but I have to apologize to all the participants that today was a unique day. We had about 16 participants on Facebook, which we never have so many participants, and there were about 27 here. So, and as this lecture is was being delivered almost at the brink of Eid holidays, today I was also constrained with the number of staff. I only had one coordinator with me, that is Sadia, and she was managing on the questions on Facebook, and I was managing on Zoom. So normally I have two assistants while the lecture is being delivered to control, to manage everything. Unfortunately, because of Eid holidays, today only I had one assistant. So maybe some questions did not come in sequence according to the queue. So anyhow, I apologize for this. If something I have messed.
Yes, but I would be very happy if they can email those questions or others. I mean, it should encourage a debate on this. And I can answer via email or any other medium they want.
That's very kind of you. Participants who have listened to the guest speaker, Mr. NAEEM DURRANI, he would welcome more questions, but on email, as we are now finished with the time here. Yeah. So you can send your questions to PSCE on our email address. Mrs. Sadia will be pleased to send the questions to NAEEM REHMAN Saab, and inshallah, he will answer your questions. Now, again, I thank the guest speaker for giving such a knowledgeable lecture and all the participants who participated so actively today. It looked to me as they were all engrossed with the speaker. Now, a few announcements. First, the Durrani Saab, your certificate and your shield, inshallah, it will be dispatched via courier mail to you in your office, and you will receive it.
Thank you very much, sir. And it has been my pleasure, actually. Thank you very much.
Thank you. And the participants, your certificates, you can collect it from 17th of May, 10 a.m. to 4 p.m. from our office located at 32B2, Gulberg 2, Main Gulberg. And the telephone numbers there are 3571-3362, 3571-3362, and we have 3 lines, 62, 63, and 64. Ahmed will be there. Ahmed Akram is always there, available from 10 to 5 p.m. You can coordinate with him and get your certificate from 17th of May. Now I have to make 3 announcements. One is, I don't know whether most of you know it, we have revamped and completely changed our website. it is now more efficient, and it works more with a higher speed. And above all the lectures prior to today's have been uploaded on our website. You can watch them free, download them free from our website. The same lectures are uploaded on our YouTube channel. You can watch them there also. And third facility is all the lectures have been uploaded on our Facebook page, Pakistan Society of Engineers Facebook page. There all the lectures are available, and today's lecture will also be uploaded in the coming days. Magazines and newsletters are being published regularly now. As you people know, Engineer Rizwan Mirza is our editor-in-chief of our publication board. Inshallah, he's working very hard now to make sure that the magazines and the newsletters are published regularly. Third thing, the announcement is, if you go to our website, you will see there a tab for loan facility. PSCE has already introduced a loan facility for the needy students of who are studying civil engineering, any university. So it's a loan facility, Karte Hasana. It is basically a Karte Hasana. Anybody you know, you can refer that student to Ms. Sadia, and there are certain there is an application and there are certain documents required, so that we have to fulfill. Then we have a full-fledged committee for approving the loan for the needy students. So inshallah, if anybody is there and is deserving, loan will be given to them. So this is also a facility which Pakistan Society of Civil Engineers has introduced. So if you have any questions regarding Pakistan Society of Civil Engineers, you are most welcome to ask them on our email, through our email. Allah will try to answer. Now, any further? I don't have any further announcements. Yeah, now the last message, which is mandatory for me to announce, that please, it comes from the Ministry of Health through Pakistan Engineering Council, that please maintain social distance. These are my views. So please, this is an announcement from the Ministry of Health that please keep on wearing the masks, as the pandemic is still there. In fact, it has become more ferocious. So please keep on wearing the masks and maintain the social distance, and try not to greet each other physically during the Eid, and avoid Eid shoppings. So that this pandemic can be eradicated from Pakistan, from Lahore, our city. And this is the message, and please stay safe. And thank you very much again. May Allah bless you all. Thank you.